Today we will be looking at this question from the 2024 AMC10. Now this is obviously a competition problem because AMC10 is a math competition in the US. Okay, so to solve this problem, we will be making use of a principle that we derived last time from the last video, which I put a link to in the description below. And it's saying that when two positive numbers have a fixed sum, the closer in value they are, the larger their product. And if we follow this rule, then the product is largest when the two numbers are equal, when they are the closest in value. Okay, so with that in mind, let's look at this problem, which I put here. So the first approach that we can take is simply to try all the choices, because this is a multiple choice question. So if we simply try the 5 choices and see what they give us, one of them is definitely the right choice. Now we would want to start from A and work our way towards E, because A is the least, E is the most, and we're looking for the least possible perimeter. So if we work from A, B, C, D to E, then the first answer that allows us to get a rectangle of integer side lengths and an area of 2024, the first choice that satisfies this is the least possible perimeter. Okay, and also recall that the perimeter is twice. So the perimeter would be all 4 sides, and there would be twice the length plus the width. So here, for example, for A, 160, we need the length and width to add up to 80. And now remember that when the two numbers are equal, that is when the area is the largest. So here, if we have a perimeter of 160 only, then 1600 would be the largest area we can get, and that is much less than 2024. So it's impossible to get an area of 2024 given 160 perimeter. So now let's try B, which is 180. Here the max area would be 45 times 45, which there's a very simple shorthand to solve this, which I also linked in the description if you want to check that out. And here it would simply be 2025, which is more than 2024. So this is promising because we know that at least when we have a perimeter of 180, the length and width are long enough to make a rectangle that is large enough. But we also need to satisfy the condition of integer side lengths. So we need to look for 2 integer side lengths that give us exactly 2024. And let's see how we can do that. Now, one thing we can notice is that 45 squared, this is 45 squared, minus 1 would become 2024. And obviously, this is in the form of a squared minus b squared, right? 1 is just 1 squared. So if we have a plus b and a minus b, that would give us 2024. And so a plus b and a minus b, a plus b is 46, a minus b would be 44. And 44 times 46 is 2024. And so we've solved this problem with our first approach. The answer is simply B, 180.